Hello and welcome to another video, this time on question 6 from 2018 paper on mechanics. Now, I can see straight away that this is a variable acceleration question. The reason being that, firstly, it doesn't say constant velocity, it doesn't say constant acceleration, so it's probably variable acceleration. You can also see it from the vector, actually. Remember, get away from the i's and j's, that's my advice to you. This is t to the minus a half and minus 4t. Okay. If it was constant acceleration, remember when you differentiate velocity, you get acceleration, yeah? And when you differentiate this, are we going to be left with constants? Well, on the y component, yeah, we will be, but not on the x component, and hence, at least in the x direction anyway, the acceleration is varying because after I differentiate this, it's still in terms of t. But yeah, generally speaking, you know, if you were to make the mistake and consider something that is not variable acceleration, you won't get the question wrong, because the principles behind variable acceleration, like differentiating, I mean, what I point out to my students is I get them to write down s, v, and a. This also works, you know, with scalars as well as vectors, but I point out you differentiate, you go down 1, and if you integrate, you go up 1. Yeah, if you integrate with respect to t, you go up 1. And that should get you to remind you how, you know, the basic principle behind any variable acceleration question. But it also works that principle for, you know, constant acceleration and even constant velocity. Because if the velocity is constant, the acceleration is 0, and therefore if v is just a constant, it's going to differentiate to 0, etc., etc. Okay, so that's basically the principle I'm going to use to answer this. Now it wants me to find the distance, which means I'm going to have to integrate v to get to s. Now I like to do this all with vectors once again. So if I'm integrating, let's do the hard bit first. I'm integrating t to the minus a half. That integrates to t to the half, increased power by 1, and then divide by half. Well, that's the same as timesing by 2. And then you must have your constants. I'm going to call this first constant c1. If I integrate minus 4t, I get minus 4t squared over 2, which is minus 2t squared. Check that differentiates back to that. Yes, it does. Plus c2, yeah? You always want to write down your constants because it all depends, basically. If it starts at the origin, yeah, then c1 and c2 in this case, because t would equal 0, it would be 0. But does it start at the origin? Well, it says all we're given is when t is equals 1, p is at the point A, and when t equals 4, p is at the point B. Okay, right, so that's all we know. So let's just set t equal to 1, and we don't know where A is, yeah? At t equals 1, s equals, okay, right, what we're going to have 2 plus c1 and minus 2 plus c2. Okay, so that's where we are at t equals 1. So we can't find the values of c1 and c2 here, but we can now say, though, at t equals 2, at t equals 4, where are we going to be? Well, we're at the point B, and so we're going to do 4 square rooted is 2 times 2 is 4 plus c1, and then I'm going to do 4 squared is 16 times 2 is minus 32 plus c2, yeah? Okay, we've got to find the exact distance AB. So let's actually find the vector AB here, because we could easily find this as a vector because we've got 2 different positions, basically. Let's call this S1 and S4, just to denote that's the position at t equals 1 and that's the position at t equals 4. To get from A to B here, then, we're therefore going to do this one, take away this one, and the C1s cancel. Or if you prefer, think of C1 and C2 here as 0, 0, and then you can see you're going from 2 minus 2 to 4 minus 32. But we're just going to be taking them away. So take them away, you get 2, we need to add 2 to get from there to there, and here we need to take away 30. And that's how we get from A to B, and hence the distance is going to be equal to the square root of 2 squared plus negative 30 squared, and that's root 904, and that's the exact distance. It might tidy up a little bit more tidily than that in terms of like simplifying the surd. I don't think it's required though, because it just says find the exact distance, and it's very easy to simplify that. Obviously, you're just going to quickly tap it into your calculator, so I think I will just in case. Root 904, okay, that's actually 2 root 226, because it's divisible by 4. which is lovely. So let's just quickly write that down. Equals 2 root 226, and that's the question done. Hope that was useful. Keep up the hard work, and bye bye.